Okay, so these are all the answers. So atomic number, you're going to get that from the periodic table, and the number of electrons is the same as the atomic number. I didn't fill it in, it's the same number. Okay, so you can fill that in, and the atomic number, you can just get it from the periodic table over here. So let's say for boron, atomic number is 5. Okay, it's the small number here. Right, so these are the answers. You can pause the video, check your answers to see if it's correct. That's one way of me drawing it. So I'm representing the electrons using crosses here. You can represent the electrons using dots as well. Oops. Okay, so in some of these examples, I've used dots. Now you can use dots or you can use cross. It does not really matter. What matters is the number of electrons are properly placed. So pause the video, check your answers. And for this one, okay, so 13 electrons, 14, 15, 16, and 17 electrons. Okay, so always be careful when you're writing the electronic configuration here. Always count the number of electrons, because if you count here, you should find that so that's 10, so that's 16 electrons. This should match with the number of electrons that you're calculating, and it also should match the number of electrons present in here. So you can count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So you should have the same number of electrons everywhere, whether it's in the diagram, in the electronic configuration, or in the one that you're stating. Okay, so always check this. And then for these ones, okay, circles don't necessarily need to be perfect. You can have hand-drawn circle, that's fine. Okay, now let's see the relationship now. If you look at the group number, let's have a look at all the group numbers. So group number, this one, let's ignore this. This one is an exception. So let's look at the group number. So group number 1. So group 1, it ends with 1. Group 2 ends with 2. Group 3, electronic configuration ends with 3. Group 4, it ends with 4. Group 5, it ends with 5. Group 6, 7, 8. Again, group 1. So whatever group number the element is found in, it's going to contain that number of electrons in its outermost shell, and then the inner shells are going to be all completely filled. So group 1, group 2. So if I tell you, let's use the periodic table. So if I tell you, let's say something that we don't really study at your level, let's say rubidium. Okay, so it's found in group 1. Even if you're not going to be asked to write the electronic configuration of rubidium, because it is in group 1, you know that it will end with 1. The electronic configuration will end with 1. So there is going to be 1 electron in the outermost shell. If you look at, let's say, tin, it should end with 4 electrons. Okay, let's say you're looking at bromine. Bromine, it is in group 7, so it should end with 7 electrons. So its electronic configuration should contain 7 electrons in the outermost shell, in the last shell. Okay, so number of electrons in the outermost shell is equal to the group number. That's the first relationship. Second relationship, let's observe the period number. So period number 2, 2, 2, 2. So what can you see here? 2, 2, 2, and 2. And here it's period number 3. Period number 3. What can you see? So period number 3, there's 2, 8, 2. Period number 2, it's 2, 7. So depending on which period it is found, you will know how many shells are being filled in. So it's found in second period, means there's 2 shells being filled. First shell, second shell. Found in period 3 means there's 3 shells being filled. Let's see. So group 3, period 3, there's 3 shells being filled. 1, 2, 3 shells. Let's see for potassium. Potassium is found in period 4. So period 4, let's see the periodic table. Period 4, potassium is in period 4. So we're filling in 4 electron shells. Level 1, level 2, level 3, and level 4. So depending on which period, so you see level 1, 2, 3, 4. So depending on which period it is, you know how many shells are being filled in. And depending on the group number, you will know what's the number of electron in the outermost shell. And normally all inner shells are completely filled. So basically you can know electronic configuration of any element depending on its period number and its group number. Okay, let's try to guess the electronic configuration of a few elements. Let's see. Let me try to, just for info, we are not studying these for now. These are transition elements and we're not studying them for now. So just ignore this block of element. Just ignore it. We're not studying it for now. We're just looking at group 1, 2, 3, 4 up till 8. Okay, let's see. You want to find the electronic configuration of silicon. Let's say I don't know how many electrons it has. I don't know how many protons it has. I don't know the atomic number, anything. I just know its position in the periodic table. So silicon, let's see. So Si. From the periodic table, I know it is in group 4. So group 4, which means there should be 4 electrons in outermost shell. So in last shell. That last shell, this is called valence shell. So that last shell is called the valence shell. Okay, and if you still remember your Form 3, there comes a term, valency. Okay, we'll come back to this term, valency. So valence shell will contain 4 electrons because silicon is in group 4. Let's see which period it is. It is period 1, 2, 3. So it is found in period 3, which means there should be 3 shells. So 3 shells filled in. So first shell holds 2 electrons, second shell holds 8 electrons, third shell, which is the outermost shell, should hold 4 electrons. So 2, 8, 4, I found the electronic configuration of silicon without even knowing its atomic number, just by looking at its position in the periodic table. It's amazing. So the periodic table is an amazing tool. So let's see something else. Let's try for iodine. Okay. Iodine, not in your syllabus, but let's see. So iodine, from the periodic table, I know it is in group 7. So it is in group 7. Group number is written in Roman numerals. So group 7, so there should be 7 electrons in outermost shell. Okay, 7 electrons in the outermost shell. Now it is in period 1, 2, 3, 4, 5. So period 5. So which means there should be 5 shells in all. Okay, so we don't know how many electrons fit in the 4th shell or the 6th shell. Okay, we don't know how many electrons fit in there. So we know that there should be 2, 8, 8. 4th shell, I don't know how many electrons it holds. The 5th shell should contain 7 electrons. So 7 electrons, that's going to go in the outermost shell. Actually, the 4th shell can hold up to 18 electrons. Well, actually, it's a little bit more complicated than this, but just to simplify things, we're just going to ignore that for now. So actually, if you count, you'll find that it does not equal to 53. Okay, it doesn't equal to 53. There's 10 missing. So actually, this number is 18. But you don't really need to know that. That's not in the syllabus. What you can be assessed on is the number of shells fill in and the number of electrons in the outermost shell. That's it. Okay, ignore. So you're not going to be assessed on how many electrons there should be inside. Okay, 4 elements above 20. So anything which is above calcium, you don't actually need to know it. Okay, but just to explore a little bit. So you could get that in a multiple choice, for example, or you could get that in maybe you'll have several options and then you'll have to choose from. Okay, so this is just how you can find the electronic configuration based on its position in the periodic table. Okay, so let's see these questions. What is the relationship between electronic structure and the group number? So group numbers gives information on how many electrons there should be in the outermost shell, and period number and electronic substructure. Period number tells you how many shells are filled in. Okay, so make sure you write this in your copybook and you include the details about group number and period number. Okay, so next video is about isotopes.